This is on top of about 2.1 volts. This is the 5000x multiplied AC part. And you can see actually the spikes, which I believe are radon or radon progeny, creating alpha particles, creating the ions that are conducting this leakage. So when you get this 20 femtoamps of leakage total, this is kind of a play-by-play. Here I am looking at air ion leakage, just a simple three plates of copper separated by air. And I'm using the ADA4530 as an analog buffer. So it's a very high input impedance. It's tied to the middle plate. The top plate I'm charging to some voltage. I have a 22 nanofarad capacitor on it. And the bottom plate I'm charging to another voltage. And that one also has 22 nanofarad capacitors. You can see them on the right there. And I'm powering everything with this lithium-ion battery. And just for safety, I have a 1 k ohm series resistor to the battery because I'm worried about damaging this. It's my last part. And so I'm being extra careful. So I'm charging those plates also with this film capacitor. I just have this 100 k ohm resistor sitting there, and I touch it to the plate and I can charge it up. And right now I have the top plate charged at 60 and the bottom charged at 0. And the middle is just basically going rail to rail, so that's 0 to about maybe 10.5 volts because of the 1 k ohm for 0.9 milliamps. And anyway, due to that, I basically see a pretty steady voltage here, about 5.6 volts right now sitting between the rails, and it slowly is going up because the top plate is charged to 60 and the bottom is at 0. Now the reason I'm doing this is because I think if I package this up like, I don't know, an aluminum foil present, I have this aluminum foil I have underneath it here, and I'm planning on wrapping it up just like a Christmas present. And then, currently I have about 75 millivolts of ripple, AC 60 hertz ripple on top of this 6 volt signal. So I want to get that ripple down, and I think I can see then radon gas disintegrations. So that's what I'm going for. So let me package this up and then come right back. Moving right along, but I have to say aluminum foil enclosures are not my favorite. About halfway there. Okay, so I have this crazy cave of aluminum foil. This is not a good idea. I need to look for some real aluminum enclosures if they have any cave style. Or maybe I'll just need to get a full enclosure and put BNC connectors or some sort of good shielding feed-throughs on one side. But anyway, I managed to do this. And just to let you know, there's 3 plates back there. If you can see them, but the middle plate is the sense, and the top and the bottom are actually charged to 60 volts right now. So it's slowly drifting up. I've connected the low noise amplifier, so I can't actually see the voltage right now, at least I can't easily. But I did just measure it, and it's about 3.8 volts, drifting up with about 11 volts on supply, so probably should not reach the rail for about an hour. And hopefully by then I can get a good soaked electrolytic. So here we have the noise of an aluminum foil floppy container. If I move around, which I'm doing right now, I guess I move this table, I shake it up, it probably has a 20 hertz resonance, and everything just kind of flops back and forth, and I'm amplifying that. So let me actually zoom in a little bit here. So you can see that it's 20 hertz. I'm not even moving right now. And speaking doesn't really couple into it well, but let me just take a step backwards in 3, 2, 1. And you see that I'm probably moving that table. And step forwards in 3, 2, 1. So okay. So maybe I got rid of my 60 hertz problem, but now I have this 20 hertz floppy problem. And I guess I need to get a solid aluminum cave type enclosure. Let me give you a look inside here. You can see the 3 plates. The middle plate is the input being buffered, analog buffer, and then the bottom plate is at minus 60 volts and the top plate is at plus 60 volts. And I had to connect the VDD directly because I need to drive it with low impedance, so I'm not using the 1K ohm resistor on the VDD anymore. I'm still using a lithium-ion battery, which is around 11 volts still. Let's zoom back out on this noise. And try to be still now. So I don't know, at times I have about a 1 volt peak to peak. So, divided by 5,000, not very good, 0.2 millivolts. That's my noise due to the vibration of the table. So another fun noise experiment. Let me think about ways to reduce this vibration. So now we have it all shielded. The noise seems low right now, but we just have to wait. If you look at that LNA from Tyler Richard, it's still only got 1 light on, so it's trying to catch up. The problem right now is that that middle plate is getting pulled on by the positive and the negative, the plates above and below it, plus 60 and minus 60. But it's slowly creeping up. It's about 2.5 volts, and it goes up about 0.3 volts every 12 minutes. So it creeps up, even though the LNA is trying to soak at that proper voltage, it's kind of falling behind. It just constantly keeps creeping. So I kind of have to get lucky at some point and have the creep end, but it should. I don't know why it keeps going up. Well, I mean, it's not that high. It's not that off balance right now, but it should kind of reach an equilibrium. Anyway, let's just review this circuit here. So we've got lithium-ion batteries at 11.4 volts, powering ADA4530, which is in this tunnel. And that's using for an input the middle plate and the top plate and bottom plate are charged at plus 60 volts and minus 60 volts. So we'll wait, come back later. Okay, so it's been about 2 hours. Let me first say I added this aluminum foil front door shield, even though I don't really need it at this point, but I did it fairly sloppily. I have this big gap. I have other gaps. I don't have a good short to the other shield. I just have kind of tools weighting it down. In any case, it's not really needed, but it did reduce the ripple a little bit. Now, at this point, since we've waited some time, you can see that LNA, both green lights are on, so the electrolytic capacitor has soaked, and here's what the noise is looking like. And the key thing here is that we see the spikes, which I believe are radon or radon progeny disintegrating into alpha particle, and the alpha particle then hits the air molecules, and the air molecules then become ionized, and then they race towards the plates. Just to remind you, inside of this, there's 3 plates. Middle plate, which is the input, which is going to the analog buffer, ADA4530. And there's a top plate, which I have charged to 60 volts, and a bottom plate, which I have charged to negative 60 volts, just to kind of balance the flow. and to create a somewhat DC voltage. And then it goes into this 5000x gain LNA, and then let's look at that noise again. And again, this is the AC part of the noise on top of about a 2-volt signal. So the battery is about 11.4 volts, and that's rail to rail then, 0 to 11.4, and it's sitting on the low side, but it's not railed out. In any case, this is the AC part on top of there. So theoretically, we have about 1 or 2 picocurie per liter of radon in the house. And with a 1 liter chamber, and inside of here was a pretty big chamber, those 3 plates, bigger than your normal radon detector. With 1 liter, you should get about 1 disintegration every 10 seconds. That includes the progeny. And I believe that's about what we're seeing here. Maybe even more. Maybe it's even more like 2 picocurie per liter. In any case, let's zoom in on the 60 hertz just for grins. This, if I am quiet, I believe will be about 100 millivolts peak to peak. So half a division here. And 100 millivolts is basically 20 microvolts before the gain stage. So the shielding's pretty good, but there's still some work to be done. I'd like to get rid of this problem and see even more details of the noise. In any case, main goal was to see the radon. And I think that is radon. You get positive and negative polarities, so right on the bottom side of the plate and right on the top side of the plate. And you tend to get them in streams, so probably radon and its progeny, we're probably seeing them both back to back. Well, there it is.